Boys and girls, welcome back to the drive-thru. Hope everyone's having a wonderful day. We are moving on into 13.3. This is systems of equations, okay? So I say let's start by thinking about all the ways that two linear equations could be related to each other. They could have the same slope, but a different y-intercept. Those two lines would be parallel, and there would not be a solution. So what are we talking about here? What's the solution to linear equations? Well, it's the point that they have in common, okay? They could also have the same slope, but have the exact same y-intercept. Well, how many points would those two lines have in common? Infinite, and that would have infinite solutions, okay? And then there's the case that we're most concerned with, and that would be if they had different slopes. Now, it might happen that if they have different slopes, they don't intersect within the picture that you could see. So, you know, they could look something like this. Well, since these two lines do not have the same slopes, they are not parallel, and they eventually will intersect. Our answer will just be somewhere way up there off the screen, and that's why we're going to have to use algebra skills, not graphing skills, to figure out these solutions. So this should be very familiar to you. This should be a pretty easy video for you to follow along with. There are two methods to solving systems of equations. The first one is the substitution method. This is best when we have something equal to y or something equal to x. So, in this case, we are going to take out y and put in 3x plus 1, because y is 3x plus 1. So 6x minus 2 times 3x plus 1 equals negative 2. So I've just substituted that in, hence the word. And we got 6x minus 6x. Uh-oh. All right, let's see what happens here. Minus 2 equals negative 2. You get negative 2 equals negative 2. Okay? So, let me explain what's happening here. Let me take this equation down here and rewrite it. You get 6x minus 2y equals negative 2. Let's write it in y equals mx plus b form. So negative 2y is negative 6x minus 2. Divide each side by negative 2. You get y equals 3x plus 1. This is y equals 3x plus 1. That's why you got to this. The answer is infinite solutions. Okay? So that was this example. They had the same slope and the same intercept. Okay? Alright. Let's find the intersection of these two lines using addition and subtraction. So let's see. 8x minus 3y equals 7. And 10x plus 4y equals 1. Well, I don't have anything that can cancel yet. So what if I multiplied, I don't know, the top one? Let's multiply the top one by 4 and the bottom one by 3. I'm multiplying both sides by 4, so I am allowed to do that. You get 32x minus 12y y equals 28, and multiply this whole thing by 3, and that gives me 30x plus 12y, okay, that's why I did that, equals 3. So when I add those two equations, I'm going to get 62x plus 0y equals 31. Divide both sides by 62, and you get x is 1/2. Okay? So since x is 1/2, I could say 8 times 1/2 minus 3 times y is equal to 7. 4 minus 3y equals 7. A negative 3y is 3. So y is a negative 1. So these two will intersect at the point 1/2, comma, negative 1. Anyone feel like booming me?